All right. Today we're going to talk about what? Oh, look, everyone looked at the objectives. Yay! A system of linear inequalities. So last week and the week before we talked about systems of equations. So how do you think a system of equations differs from a system of inequalities? It's the same thing except... it's the same thing except what? What's different in the title? System of equations, system of inequalities. So, yeah, what's the difference between an equation and an inequality? It has the less than or equal, greater than or equal, less than, greater than, stuff like that. That's an inequality, right? So when we graphed when we graphed a system of equations, where was our solution? At the point of intersection, right? Where they crossed, okay? When we graph a system of inequalities, we're going to have to figure out the solution, okay? We'll get to that in just a second, but I need us to go back to the last time we talked about inequalities. Do you remember what we did after we solved it and got an answer? What did we do with that answer? We graphed it, didn't we? Okay? Because if we're trying to solve an inequality, we get an answer like x is greater than 2. How many answers are there, really? If it says x is greater than 2, how many numbers are there that's greater than 2? Yeah, absolutely. An infinite number of solutions, right? So what do you think is going to be different when we graph a system of equations versus a system of inequalities? We're going to have an infinite amount of answers. That's exactly right. When we graphed a system of equations, we had 1 point. Now remember when we graphed on a number line inequalities? When we graphed x is greater than 2, I put like an open circle or a closed circle on 2, and then I did what? Yeah, I shaded, right? I drew an arrow on the number line. Guess what we're going to have to do when we graph a system of linear inequalities? Shade, absolutely. Okay? So let's look at a system. What would a system look like? Well, I like to start off slow so I don't freak you out. Is that okay? So let's start off with something like this. Okay? Let's start off with something like this. X is greater than 1. How do you graph that? You remember when there's only one variable, it's telling me which axis it's crossing and where. Which axis is this crossing? The x, where? At 1. To cross the x-axis at 1, it has to cross right there, doesn't it? Now, look here. That sign, what did it tell me before when I graphed on a number line? It told me either open circle or closed circle. Exactly. Okay? It's telling me the same kind of information now, but I don't have an open circle and closed circle. I have to draw a line. So what kind of a line might it be? Well, by definition, lines are straight, so that's good. Okay? Let me help you out with this. It's been a while since you've done this, all the way since Algebra 1. So, 2 or 3 years, something like that, right? Okay? This kind of inequality symbol, when we're graphing in a coordinate plane, is either going to tell me if it's a dotted line or a solid line. Do you remember that? Now you do. Okay, good. So, do you remember if this is a solid line or dotted line? A greater than symbol? Why is it a dotted line? What would make it a solid line? The equal to, right? If it's greater than or equal to, it would be a solid line because it's also equal to. But because this is just greater than, it is a dotted line. Okay? So I'm going to draw a dotted line. Just like this. Now, I need you guys to be a little clear about what I'm about to do because I don't actually teach this part exactly the same way that's in the book. But I think that you will like my way a little bit better. Especially if you are a visual person and need to see things for stuff to happen. Okay? Where is x greater than 1? On which side of the line is x greater than 1? on the right side, right? The right side of this line. So instead of shading everything right now, which is what the book tells you to do, like lightly shade, I'm just going to tell myself where I would shade if I was going to shade. I'm not actually going to shade, because once we get 3 lines on here, which is what we're going to end up with, 3 or 4, there's going to be tons of places that's shaded, and I may lose where my answer is. I don't want to lose that. Okay? So for right now, I'm just going to tell myself where my answer is. Does that make sense? Okay. So what happens then if I add another equation, or excuse me, another inequality to my system? What if I say y is less than 5? How do I graph that inequality? Perfect. It hits the y-axis at 5. 1, 2, 3, 4, 5. So it goes like this. Right? You said it's a dotted line, right? Dotted line. So I can't say that it's shaded on the left side or right side this time, because there's not a left side or right side. What kind of sides are there this time? Top and bottom. So am I shading above the line or am I shading below the line? Why? That's where the y's are less than 5. That's perfect. Okay? So I'm going to tell myself it's down here. Why didn't I put any arrows over here? Yeah, I already know it's on the right side of my purple line, right? I can tell myself, yeah, it's down here, but I already know that my answer is not going to be over here. My answer is going to be somewhere right now. It's going to be somewhere right here, isn't it? Okay. So I'm going to add one more equation. Okay, I'm going to add one more equation to my system so you guys get an idea of what's going on. And that last equation I'm going to add is y is greater than or equal to x minus 6. Okay, so how do I graph this line? Is this different from the other 2 lines? Why? Because it has 2 variables. Okay, so a lot of times people say, oh, that's a diagonal line. Not a straight line, but a diagonal line. Okay, well, by definition, lines are straight, whether they're diagonal, horizontal, or vertical, right? Okay, so, but do you get the idea of what they were trying to say? Me too, okay? So how am I going to graph this line? What do I have to look for first? What's that called? It is called -6. Excellent. It's also called the y-intercept. It's where this line crosses the y-axis, right? So it's at -6. 1, 2, 3, 4, 5, 6. Once I know it crosses at -6, what do I use to create the rest of the line? The slope? Right? The slope? What's the slope in this problem? Let me write this. Maybe this will help. That was the y-intercept, the b. The m lives in front of the x, the slope. So it's 1. Okay? So from here, I do what? What do I do? From my y-intercept, I rise 1 and I run 1. Excellent. Now, some people have just drawn 2 points or 3 points and drawn a line from there. But guys, does it really take a whole lot of time to rise 1 and run 1 all the way across the graph so you know for sure where your answer is? Isn't it better to just be sure? That didn't really take a long time, did it? The answer is no. No, it did not. Okay? Now, what kind of line is this? I know you already told me it was a solid line or a straight line, right? But it's a solid line as well, right? It's not dotted this time like the other 2 are. And where would I shade this line? So maybe I didn't know the trick, the shortcut. And if you don't know it, I'll teach it to you in a second. But let's say I forgot it. I need to know if I need to shade on this side of the line or on this side of the line. Is there a way I can figure out where? Couldn't I pick a point somewhere on one or the other sides of the line and substitute it into the inequality? What's the easiest point to pick? 0, 0, the origin, right? So if I put in a 0 here for y and a 0 for x, I get that, right? 0 is greater than or equal to negative 6. Is that true? 0 is greater than or equal to negative 6. That is true, right? So what side of the line should I shade on? The wherever the 0, 0 was, right? So I'm going to shade up here. I'm going to shade up toward the origin. So in this particular case, wait, how do you know that's the answer? How do you know that's the answer? You said the answer is in that right triangle. Oh, so where everything is like pointing to, that's where I should shade? Your correct answer is absolutely. Okay? So this is where I would shade. It would be really dark, and sometimes it's hard to see when you shade too much. Okay? Some people can handle it. I thought you guys would be better this way. Okay? So how many answers do I have? How many points are in that triangle? How many points are in that triangle? How many points are in that triangle? There's an infinite number of points in that triangle. So he was trying to think of all the the integer points, right? All the exact ordered pair integers, numbers. You know what I'm trying to say, right? I'm clearly not saying it well today. I'm sorry. Okay? He was trying to find all the exact points. Except, isn't 0.5 in the shaded area? Yeah? And that's not something I'm going to be able to count. Because I can always go halfway from that. So I could go a fourth, or an eighth, or an eighth. And I can always go halfway from what I went before, right? So that's why there's an infinite amount of points in that triangle. But I would like you to tell me one possible solution to this system. 1, 1. Okay, she says 1, 1. 1, 1 is right here, right? So is that allowed to be one of the answers? Well, the way we could figure it out is by plugging it into every inequality, right? So x is 1, y is 1. 1 is greater than 1. That's not true, is it? Okay, so is that okay? So is 1, 1 really a solution to this system? No. It would have to be 2, 2. So like right there, would that be a solution to the system? 2, 2 would work. That's a yes. Okay? So can I be argumentative? Is that allowed? Oh, I mean, I can. Believe me. I can. I'm just asking if I have your permission to try something with you real fast. 6, 6, 0. Is that a solution? Where is that? It's on the line, isn't it? You said over here this one doesn't work because it's on the line. Does it work? If x is 0 and x is 6 and y is 0, 6 is greater than 1. Does that work? 0 is less than 5. Yes, that works. 0 is greater than 6 minus 6. So 0 is greater than or equal to 0. That's true, isn't it? Because it's greater than or equal to. And it is or equal to, isn't it? So 6, 0, even though it's on the line, because it's solid. That's exactly right. That's exactly right. Okay? So if the point lies on a dotted line, it is a solution or it's not? No. But if it lies on a solid line, okay, so can I make it even harder? What about this point right here? Uh-huh. But it's also on a dotted line, so is it a solution? Will it work for every one of these inequalities right here? No. Okay? Just something to think about. Just something to think about, okay? So, several different things you're going to have to do for homework tonight. Actually, really only two. Okay? First thing I'm going to have you do is I'm going to give you a system. You're just going to have the equations. The inequalities. Okay? And I'm going to say, is this point 1, 1 a solution to this system? If you didn't have the graph, how would you figure out if it's a solution to the system? Perfect. Just plug it in. That's exactly right. Hard or easy? Easy. Okay? The other thing that you're going to have to do on your homework is I'm going to give you a system of equations, and you're going to have to graph it. Done. One question on, here's the system, is this point a solution? 4 questions on, here's the system, graph it. Okay? Now, some earlier classes accused me of what I don't like to be accused of, giving you harder problems than I gave you for the example. So I feel like I need to show you one of the harder problems that you're going to see. This was a harder problem that shows up on your homework that I didn't show you in the example. Can you hear the sarcasm drip off of my voice? Okay, is this really a harder problem? Well, it's not in slope-intercept form, and that's what they were complaining about. So what you have to do is subtract x from both sides and get y is greater than or equal to negative x plus 5. Do you know how to graph that? Oh my goodness. I made sure they had Kleenexes since they were crying about it. Just teasing about that. I don't want to waste my Kleenexes. Negative 1 this time, right? So you'll go up 5. 1, 2, 3, 4, 5. And then you'll go down 1, right 1. Down 1, right 1. Could you also go up 1, left 1? Is that allowed? It is, right? Okay. Any questions about that? So you guys have the rest of the period to work on this. Ask me questions as you go. You can come check my book as you go to make sure you're getting it right. I want your confidence for this. Okay? Oh, really quickly, look at the sideboard. Look at our upcoming events. Monday, today is new topic. Tuesday, another new topic, but it's related to this stuff. Okay? I mean, I'll even tell you what it is, so it's like you have something to look forward to, right? So today I showed you the system and asked for the graph. Guess what I'm doing tomorrow? I'm giving you the graph, asking for the system. Oh, you guys were jealous of my sticker, weren't you? I saw you being jealous of it. It's Unicorn Moon. Isn't that exciting? Yes, it is a Lisa Frank sticker. Okay, Wednesday you have a review. Thursday you have a test over 2 days of material. Today and tomorrow. Friday you have the Unit 3 assessment, which is all the systems of equation stuff, and then all the systems of inequality stuff, which is what we're doing this week. Okay? Yes? Okay. Any questions? Okay. Peace.